Hi, I'm Takumi Hamazaki, from UEC, Japan. I'll be presenting ALCool, work I did with Taiki Takami, Keigo Ushiyama, Izumi Mizoguchi, and Hiroyuki Kajimoto. In this study, we demonstrated that by using the endothermic effect caused by the volatilization of alcohol, it can present powerful cold sensation in low power, compact and easy. Additionally, our findings indicate that employing commonly accessible alcohol, such as perfume, can enhance the cooling effect. Thermal sensation is essential for the user experience. For example, this sensation plays a crucial role in recreating VR environments, emulating the texture of objects, communicating information, and eliciting emotions. This sensation includes two primary sensations, warm and cold. Providing a sensation of warmth is relatively easy, as it involves a direct conversion of electrical energy into thermal energy. However, providing a cold sensation often requires a large amount of power, such as Peltier elements, or a bulky device using water, according to the second law of thermodynamics, which states that energy flows from higher temperatures to lower temperatures. Therefore, our research focused on the presentation of the cold sensation. Researchers have proposed low-power and compact methods of presenting cold sensation by directly stimulating nerves and receptors using electrical stimulation or chemicals. Yet, these methods often require specialized equipment and special chemicals available on the market. There have been challenges to mainstreaming. To tackle these problems, we focused on alcohol. Although you may have daily experienced the sensation of cold by applying alcohol, it has not been used as a tactile presentation method until now due to availability issues. However, alcohol has become widespread after the COVID-19 epidemic. For example, on campus, alcohol is available in the hallways, cafeteria, shops, and entrance. Therefore, it is particularly timely and beneficial to explore tactile presentations using alcohol. First, as a prototype of the haptic presentation method using alcohol, we developed a wristwatch-type device like this one. This device is divided into two parts, a case and a cartridge. The case part consists of a fan, a control unit, and a battery to promote evaporation, while the cartridge part consists of gauze and a tray. The size, weight, and power of the device are here. Comparing the power consumption when cooled to the same level with conventional Peltier devices, there is a large difference, ranging from about 30 to 80 times. Next, we examined the proof of principle that the combination of alcohol and a fan can induce a strong cold sensation and compared it with conventional methods. We measured the amount of skin temperature decrease. There were 3 participants in the measurement. The procedure was as follows. The thermistor was attached to the skin and measurements were taken for 180 seconds. The start time of the device was set to 0 seconds, and the drive power was controlled to 0.35 watt. The conditions are as shown here. The parameters of the conditions are divided into the presence of alcohol cartridges and the direction of the wind. The direction of the wind is the towards condition, in which the wind is blowing directly on the skin, and the away condition, in which the wind is blowing upward through the skin. Yellow is our approach and gray is the conventional Peltier device. As a result, our approach C1 and C2 demonstrates a marked significant decrease. The following are excerpts from our approach and conventional methods only. C6 and C7 are only down to from 1 to 2 degrees Celsius, while C1 and C2 are down to from 6 to 7 degrees Celsius. This result indicates that our proposed method generates a stronger cold sensation at lower power than Peltier devices. The use of alcohol made it possible to produce a strong cold sensation. But the problem was that only a cold sensation produced. And the sensation gradually weakened as the alcohol evaporated. In the user study, we focused on a familiar alcohol, perfume. Perfume is mainly composed of alcohol and fragrance, and the evaporation of the alcohol causes the diffusion and change of fragrance. Some fragrances contain chemicals that can directly stimulate receptors, such as mint and eucalyptus. Therefore, in this study, we hypothesized that in addition to the cooling effect resulting from the physical effect of alcohol, the sensation could be further enhanced by the cooling perception induced by the neural effect of fragrances. There were 14 participants in the study. Each condition lasted 30 minutes, with 30 seconds of upward airflow every 5 minutes. Participants responded to a Likert scale every minute or when the thermal sensation changed. The Likert scale was a 9-point scale, with -4 being very cold, 4 being very hot, and 0 being no sensation. 3 conditions were used: fan only alcohol, and perfume including menthol. The results are here. The range was set from 0 to -4 because no warmth was generated. The solid line shows the start timing, and the dotted line shows the end timing. Therefore, the peak occurs at each airflow timing. Focusing on the fan only. Under these conditions, the peak value is small and low when wind was not presented. In contrast, in the alcohol condition, the first peak is significantly higher, but it decays with time. This result seems justified because of the evaporation of the alcohol. The alcohol in the perfume should also volatilize, but unlike the alcohol condition, the perfume condition was continuous high from the first peak value. Let's move on to the discussion. These results suggest that the perfume composed of menthol and alcohol enhanced cold sensation, compared to alcohol alone. One possible explanation for this effect is that the chemical stimulated skin receptors. However, cold sensation might have been enhanced by the olfactory sense kind of cross-modal effect. Interestingly, by replenishing alcohol in the cartridge after applying perfume, both the scent of the perfume and the cold sensation were revived. This phenomenon may be due to the presence of non-volatile aroma chemicals residues in the cartridges. Therefore, previously exclusive to olfactory experiences, perfumes can now enhance tactile sensation as well. Utilizing the smell and cold sensation revival effects obtained in this user study, we created a tactile and olfactory timer. The user is given perfume only at the beginning and works for a certain period. After a certain period, the user feels the aroma and tactile feedback. Supplying with alcohol at break time revives the effect without the need to replenish the perfume. This application can achieve a reduction in perfume consumption. Here is a video of the VR application. In this demo, alcohol is represented as the magic point MP. Initially, the player has access to powerful spells, but as the alcohol evaporates, his MP depletes, resulting in weakened spells and sensation. Here, by using the HMD's pass-through, he can replenish their alcohol-based MP from the real world, allowing them to cast strong spells once again. Thus, we have integrated alcohol-specific phenomena into the event. To conclude, we developed a wearable haptic device that utilizes the volatilization of alcohol. Our results indicate that this device is more efficient at producing a more intense sensation of cold than Peltier devices, while operating at a significantly reduced power. Finally, we found that the use of perfume enhances cold sensation. Please see our paper for more details. Thank you for listening.